Hello and welcome to Ngwasheng Mathematics Online Academy. Now, as this is the first video for the grade 11s mathematics, if you follow the previous shorts that I uploaded, I indicated the plan as to what is it that we're going to do on this channel. We are actually offering mathematics lesson from grade 8 up to grade 12. However, when we upload, we're going to upload videos for separate grade. Like I indicated, as you can see, this video is strictly for grade 11s, but we know that even the grade 12 that can still benefit on this, even the grade 10 as well, because this topic is also from the part of grade 12 and 10 syllabus. So, but strictly this is for grade 11s. There will be a separate video for grade 12 and separate video for grade 10, 9, and 8. Basically, from 8 up to 12, there'll be different videos for different lessons, as I indicated on the previous shorts that I uploaded. Following the ATP, of course. All these grades, we follow the ATP, annual teaching plan. What is it expected from school level, especially for term 1? Since South Africa, we are also following terms. We don't just teach anything that we like. So term 1, everything that I'm going to present from now, it will be under term 1. And then once I'm done with term 1, I'm doing term 2. This goes across all the grades. If you check the annual teaching plan, it tells us that this term of term 1, 2026 for the grade 11s, this is the first topic to be covered. So the entire purpose and the aim of this is to give learners an access for an alternative learning. So as now, I decided to follow the ATP. So as you can see, this video was recorded on this date. Now, make sure that you subscribe, you like, you share, you comment as well. It's going to help the channel to grow. And obviously, commenting is important because it's a way of communicating with me as to if you are suggesting what you want us to cover or you seek clarity on whatever that you're going to deal with here. So now, like I said, welcome. Welcome again. My name is Desmond Ngwasheng. I'll be your tutor. I'll be your math teacher under this channel. All right, let us start. Now that I already explained that the lesson is based on the exponents and surds, we are going to touch on this. I took all this problem on past papers. So meaning everything that you see, it is for examination purpose. We know our textbook mostly, they just give you a lesson that is much simpler compared to exactly what they are asking in examination. So it is much better if we deal with what exactly you're going to get in examination or the structure of how they ask questions. Okay, now looking at these 4 problems, I always advise learners to make sure that have a very sharp eye, be able to look at the problem. After looking at the problem, you obviously observe and see how best can you answer these questions or how best can you work out this problem in terms of providing the solution. Like as you can see, there is somehow differ. This one is not the same as that. However, 2 and 3, they kind of look alike. The difference is that number 2, these 2 terms, they are separated by a subtraction. However, number 4, they are separated by a addition. Number 3, obviously, multiplication. There's something common amongst all of them. But we'll see as we proceed. So where there's a problem, there's a solution. Now that we're talking exponent, don't forget we have exponential law. Learners need to memorize exponential law. It will be easy to tell that here I'm going to apply law number so and so, or here I'm applying this law, here I'm applying this law. Identification of exponents is very important in this matter. So now I can now indicate to say we have, let's say, exponential law. I'll just say X law. Number one, when you multiply the same base, we actually add their exponent. Law number two, when you divide the same base, we subtract their exponent. If you look at this, we simply follow what the law says. This is law number one, number two, and then three. Basically, can have something of this nature where you've got x2, maybe with a 3 outside. What does this mean? The exponent outside multiply the exponent inside. So it's something of this nature where we are having now 3 times 2 or 2 times 3. The order doesn't matter, but we still get a 6. I'll end here with 3. Because now we can tell that we are going to apply only these 3 laws according to what I have. Nobody's going to tell you that, please use this method, do 1, 2, 3. No, we just give you a problem, then you work on your own. Now, there is instruction though. The instruction that they can give you here and nothing more. They'll just ask you to simplify. Period. Done. This is too much, actually. They're done a lot. By just saying simplify, they're done. It's up to you to see a way forward. But let's talk about this term, this word, simplify. The word simplify has been derived from the word simple. So what are they saying to you? Can you make this to be more simpler? Oh, this one. Meaning they're kind of a bit complex. Make them to be less complex. Make them to be simple. So basically, we're going to do that. Of course, with the assistance of following the exponential law. Hence, I say, this law, even in grade 10, they were covered. Unless if you're not paying attention. Nothing is new that we do in grade 11. Still go back to grade 10 and 9. Okay, now, let's start with the first one. If you want to understand everything based on the exponent, this lesson is for you. I'll also touch the sets, which can be on the next video following this one. I'm still going to do the equation and so on. Just look at the shots that I uploaded before. They just tell you what comes after exponents and surds. I'll just follow that. Now, let's start with the first one. Since you're talking exponents, we need to make sure that if I'm given a whole number, I have to manipulate or change this number into exponential. Now, you can ask yourself, what is the exponential form of 125? Some they can just punch this on a calculator. Some they already know what is the number. Doesn't matter how you do it. The bottom line is we need to change this into exponential. Looking at this one, there's no need to change into exponential. Our base are already in the simplest form. Unlike this one, is not simple as 4. When it comes to number 3, I just have to worry about 4 and 8. And the last one, of course, number 4, I'll change 4, 4, 12 into exponential form. Now, let's do this one. How to change 1 to 5 into exponential. Look for a number that when you multiply by itself, it will give you 125. What is that number when you multiply by itself? It gives you 125. But because of the unit is 5, I can start there by looking at 5. So 5 times another 5, that's 25. But 5 times 5 times another 5, that's 125. That's searching for that number. But however, you can also use a calculator. Calculator, we only use it like to save time, because in examination, you are somehow limited. The examination can be 2 hours long, 1 hour 30, so you are limited. We only use calculator for such reason, to speed up the examination. Now, to those who might use a calculator, you're gonna press 1, 2, 5, equal sign, which is equals to, and then you press shift. This is depending on the nature of the calculator that you are using. Shift button on your calculator. Some they use this second fraction like this, depending on the calculator. 125 equals to shift. After shifting, then you're gonna press, look for these weights representing exponent on a calculator. It's just gonna give you something like this. This is a learner who's using a calculator. But manually so, we said look for the number when you multiply by itself, it will give you 125. So I check by saying, I obviously know that 5 times 5, that's 25. But furthermore, if you say this 25 times another 5, that's when I'm getting a 125. So how many 5 did I use? 3. Remember, when you multiply the same base, you add their exponent. We did that. When you multiply, you add. So it will be like 5, 1 plus 1 plus 1, which gave me 5, 3. So the exponential form of 125 is equal to 5 cubed. So now I'll come here and write 5 cubed. With a 2 over 3 as an exponent or index. That is just a different terminology representing the same thing. Now, if you check carefully now what we have, we've got the exponent outside the bracket, obviously, and the exponent inside. It takes us to law number 3. What do we do? The exponent outside multiply with the exponent inside. Then let's follow that. This is our 5. 3 times 2 over 3. Basically, I just changed the bracket into multiplication. We know that is doable. And therefore, if you check, since I have a numerator of 2 and a denominator of 3, I can also manipulate or make this to be similar. Since this is my numerator, I will create my denominator by putting the invisible 1. Now, it means when it comes to simplification of this, like different learners apply different method. Some, they will just cancel 3 and 3 and then write down what is that is remaining. I'll show you another option or method basically. So I only have 5, obviously, because I was sorting out this mess. I'm left with 2. Okay, we can stay 2 over that one, but you and I, we know that 1 cannot change anything. So basically it's the same as just 5 squared. Now, Never leave your answer as in an exponential form. From the start, we change into exponential, but it was a whole number. Towards the end, the exponential will take it back to the whole number. So what is 5 squared? Is 5 times 5, which give us 25. That is the end. This is what they expect from you in examination. Now, back to this part. We said some learners, they can just cancel, but another method, a learner can go straight, meaning multiply numerator times another numerator, which is 3 times 2. It will give us 6. Then 1 times 3, it will give us 3. Then how many times does 3 go into 6? Twice. So it's the same because we still got a 2, even when you do the cancellation method. That is problem number 1. Now, let's move to 2. I think how I presented this, I started with the easiest and going to like up to the most challenging one. Now, let me clear this part. Let me clear this part so I can work out problem number 2. This is not clean. You know, you can pause and do other problem before I actually work them out. If I provide the solution, you know, pause, work it out yourself, and check. If you find that you are correct in everything, then that means you are good, you are winning. You'll only check where you are now struggling. Most learners, they've got this attitude that I know. And for that matter, it affects them. Even if you know something, do it. I will tell you that it starts by you having idea of what is happening. The more you do it, now it's not a matter of now I get it. Basically, you understand. If you understand and you still do it more, you are actually eliminating the mistake that you are doing in examination. So don't say, I know, for that you don't do it. That is my advice to you. Let's come to number 2. Problem number 2. And again, okay, going back to number 1. Remember they said simplify. And I say this means simple. From this look complex at first to just 25. You can tell that now this one is very simplified. Basically, they wrote 25 in this form. Everything here basically is equivalent to 25. You can tell this is simplified. That makes it to be complex. Let's come to this. Let's simplify this. Now, every problem has a different approach. But at some point, because they are under the exponent, there's something common about them. Because they all have exponents. They are written in exponential form. If you check, this base of 3 consists of the exponent of 2 terms, x plus 1. But now, I don't have to worry about changing a whole number into exponential form because they're already simplified. Obvious, 3 is just 3 to the power 1. There's nothing I can do. So leave it as it is. That means there's something else that we have to do, which is what? We say, if you've got a base that has exponent by means of a binomial, is an exponent that has 2 terms, then split this exponent, but they still have to share the same base. So in short, we say let us split. This is me splitting. I'm having 3x, and when you split, put the multiplication. There, I split x plus 1 into x and 1. Then minus 3x times 3 minus 1 all over 2 3x. Now let's talk about this step. We split the base of 3 into 2 different bases with exponents, different exponents. There were 2 of them, x plus 1. Now x is separate from 1. But when you take this back, when you look at this, when you say 3 times 3, when you multiply the same base according to law number 1, again, 3 times 3, they are the same base, is not 9. We know, misconception. We are actually multiplying the same base and add their exponent. It takes you back to original. Same applies to this one. 1 is there, x is there, but the base. What is the purpose of doing so? Well, there is a problem, there is a solution. It's just a hidden solution. This has been hidden for you. Hide and seek kind of a thing. Now, if you look at the highlighted ones, these are the same. What do? We must take out the common factor. So what is common is this, the one that I circle with the red. So if I take 3x, I'm going to write this bracket just to indicate what will be remaining if I take out this 3 to the power x. But here I don't have to, because it's only 1. 3x. As long as there's no addition or subtraction, we won't talk about common factors. Now, in a space where there was 3 to the power x, we replace with 1. There's my minus. Where there was this 3 to the power x, I will put 1. And then there is 3 to the power -1. So I like this kind of problems because basically there's something obvious about them. Cancellation. There's a cancellation that is going to take place. We're going to cancel this and that. Just because of this is separated by a multiplication or a bracket. Never cancel from original where you just, that is a misconception. Like learners will just cancel whatever that looks similar. They'll just cancel. But we only cancel once we experience that my numerator is similar to my denominator and there's a multiplication that separates this or a bracket. So in this case, now you can see that the x is gone. The x is gone in this matter. So what it means, I'm going to use this space here. It means sort out your numerator. Simplify your numerator first, because when you look at your denominator, it is simplified on its own. So the only challenge can be on this part. Most learners, they just punch calculator and get to the final answer, which is a way of you guys losing some marks because you don't know what the marking guideline says. When we mark, we don't just mark every step. There are some steps which are really meant to be marked. But when you skip, you're not sure which mark or which step is important. So just do everything. Now, the calculator doesn't recognize Botman's rule. Doesn't recognize that. You can be lucky when you punch everything, you get the answer. But sometimes you don't get it. When I say Botmas, obvious, anything that involves brackets and exponent, blah, blah, we work on it. Actually, this can be like PEMDAS, depending on, like for instance, we know this is for brackets. Now, this is strictly for exponent. Why this? Because I can see the exponent there. So meaning I can apply the PEMDAS. How? I will start, I don't just say 1 times 3 to the power, never. Sort out the exponent part. So what is 3 to the power 1? Is 3. You see, because I sort out the exponent, the next step I'm going to multiply, which is I now have to say 1 times 3. Okay, let's now work on this. It's also an exponent. When I simplify this exponent, it takes us back to when we change fractions into exponential form. 1 over 2 will tend to be 2 to the power -1. Basically, if I have a 3 to the power -1, it will tend to be 1 over 3. So go back and remind yourself of this. We were talking about the fraction into exponent, the negative exponent, and so on. It will be a vice versa thing. we give you this, it tends to be like that. If I gave you this, it tends to be like this. That is another lesson. So I'm trying to sort out this mess. Now we have this. For understanding purpose, I'm forced to indicate these steps because some learners, if I skip step, we're still going to ask questions like, how did you get here? As a teacher, I know if I'm doing it for myself, I can skip a whole lot. Like I can give answers by inspection. But because we want to teach somebody out there, we have to indicate everything. And make sure you watch this video to what's until the end, basically, until the end. All right, now I said we worked with exponent, meaning just 3 to the power 1 is 3. 3 to the power negative 1 is 1 over 3. So we are done with this part of exponent. What comes after? I still have a multiplication here between these two numbers. I still have a subtraction. But if you look at this, it's towards the end. That is the last thing to do. So meaning now I must work out on multiplication. The multiplication part is where we say, what is 1 times 3? That's 3. What is 1 times 1 over 3? 1 over 3. All over 2. I'm sure learners, they forever punch a calculator and just give you the final answer, which is like, basically, that's not part of learning. You are just rushing to provide solution where you cannot even explain to the next person, how did you get to the solution? Now, due to the space, I'm going to proceed on this part, hoping that at least I'll be able to write the final answer. So from here, let me come there. I don't have a calculator, but I'll somehow sort out this. If you check our denominator, it's like it's simplified. There's nothing we can do. But now let us sort out this mess. Since this is 1 over 3, now this will be 3 over 1. So let me find the LCD. The LCD here. 1 times 3 is 3. Then we start with the right hand side. Since well, it's I'm experiencing there is a negative there. If it was positive, it don't matter. But now, if I say 1 times 1, if I start on my left, I'll have negative 1 and then end up with, so it will be something like this. So we start with the right hand side. 3 times 3 is 9. And therefore, 1 times 1, it's 1. All over. Remember, this 2 is still this one. So what is 9 minus 1? Basically, we're having 8 over 3. All over 2. Now, from here, since, well, this is a numerator and a denominator divided by, this is our numerator, we can create a denominator for that. Then we'll say 8 over 3. Now, due to BODMAS, which I cancel the PEMDAS there, after division, we multiply. So now I want to manipulate this division into multiplication. So it means I move from here to here. And the only time you do this, swapping or changing this sign into that means even this fraction should be switched. 2 over 1 will be 1 over 2. That is like the reciprocal. Now, in this case, 2 into 2 into 8 goes 4 times. You can say 2 into 2 goes once, but 2 into 8 goes 4 times. So what is it that we have? We are having 4 times 1. So it's 4 over 3 times 1, 3. So now this is our answer. But I know learner A already punched everything here, including these two, and just get straight to the answer. That's how you fail mostly. Because for a problem that is like 5 marks, and then you just punch everything, you get answer. You might find yourself that you just lost 2 marks. Then out of 5, maybe you got 3. Avoid that. You don't waste time if you're doing something that you know. So let's move to problem number 3. So I hope you follow everything that I'm doing here. I said to you, pause the video so you can work out on the solution yourself. Compare our solution with yours. On the comment section, let's communicate. Where are you watching this video from? This lesson is recorded in South Africa. Saudi, South Africa. Yes. Now, all right, let me clean this one because we are done with this one. Okay. Now, we're gonna do problem number 3. Biza bangani bazobona le video. Tell your friends to tell your friends to watch this video. Now, if you check, the first problem was different to the second problem. And now we are doing problem number 3. I repeat, all of them, they are exam-based. Exam-based questions, all of them. Now, let's work out problem number 3. Look at the problem itself. Look at the problem itself. Ask yourself some questions. Will I apply the same method that I applied on the previous one? Not really. Some. The previous one had a subtraction. And anytime we have the operation like plus or minus between 2 terms, definitely we are forced to take out the common factor. For cancellation purpose, I cannot apply the same thing while I'm having a multiplication. But it doesn't change the fact that we still have to change the whole numbers into exponential form. Looking at 2 is already simplified, but I can work out on 4 and 8. This is much simpler. Now, remember, 2 is just a whole number. To make it exponent, obviously there is just 1. Hence, hence I said it is simplified. But when you say 2 as a whole number, change 4 into exponential. Math is using the same numbers over and over. So we know 4 into exponent become 2 squared. What does this mean? Basically, 2 times another 2. Same number multiplied by itself twice. According to this, it gives us 4. Now, we have 8. 8, we don't say 4 times 2, but it's 2 cubed. Why? Because it's 2 times 2 times 2. Most learners, they've got a misconception of saying 2 times 3 is 6, while we're having 8. So basically, this means 2 times 2 times 2. That gives us an 8. Because 2 by 2 is 4. That's 4 by 2, then 8. However, some they will say, okay, 2 times 2 is 4. It looks like as if it was 2 times 2 is 4, which is why they say 2 times 3 is 6, which is wrong. Follow? Now, let's change this. It means I'm going to change this. Meaning 2 will remain as 2. 4 will be 2 squared. But now that I created a new exponent while there was an original exponent, they share the same position. You just have to separate them by a bracket, which is we're going to multiply on the next step. Now, for 8, we said it's 2 cubed. 8 here, 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 here. We said 8 is 2 cubed in exponential form. Also, 8 had an original exponent of n minus 1. They share the same position. Basically, we're going to multiply on the next step. That is us simplifying that. So I can take it to my right. So the first one is not affected. I'm rewriting it as it is. But the second one, special this, I have to say what is 2 times n, what is 2 times 1. So I'm having a 2n plus a 2 for this part. All over this side, I'm having a 3n minus 3. I just simplified our exponent. Now, let's see. In this case, this is where we can now apply our law. You can see we've got same base, multiplication of the same base. I can apply law number 1. Once I'm done, I still have a division of another same base. I can now apply number 2. So there are different methods. I'm going to highlight both of them. Method number 1, a learner who will simplify the numerator first. That learner is going to say n plus 2. Let me use a different color to indicate. When we say, when you multiply same base, you add their exponent. So this is me adding. Let me use the red one so you can see. And then the other one remain as 2n plus 2. So I actually added the 2 because they were separate multiplication following exponent law number 1. This is what I applied for this one. But now coming to this one, I'm writing it as it is. I prefer to indicate steps so that there's no question after a lesson. Everything should be clear. Now, what is it that is remaining? Let's simplify what we have here on our numerator. So we are having n plus 2n. Knowing that this n has the invisible one, so basically is 1n plus 2n. We take the sign before the number that you're dealing with. So if I'm referring to 2n, 2n is plus, is positive. So basically is 1 plus 2n. It's going to give us 3n. Now we are having 2 plus 2. They're both positive. They add each other. That's going to give us a 4. Therefore, we are having our denominator, which is ready-made. We don't have to worry. Then that's 3 minus 3n. Now, if you check, now we are having a division of the same base. A division of the same base, which is, now we are here. When you divide the same base, you're basically going to write one base that represents both of them, and then do the magic with the exponent following the law. So I'm firstly rewriting the first one as it is. Basically, the top minus the bottom. The top one, you write it as it is. So now we say minus the top, the denominator part. So this was the numerator, is part of the numerator. We minus the one that is a denominator. So let me, with a different color, indicate 3n minus 3. I always say, failure to put a bracket while you're dealing with a negative, forget, especially when you've got 2 terms. Yes, if it's 1 term, it won't affect. But with 2 terms, it's going to affect the next term. So I'm having 3n plus 4. So I can say negative times 3n is negative 3n. Negative times negative 3, that's positive. So for somebody who's not putting the bracket, your 3 will come out as negative. Then you're out, forget. So now we are having the like terms, meaning 3n minus 3n. Basically, they won't exist anymore. 4 plus 3, it gives us 7. Now, that is basically 2 to the power 7. If you follow the steps, you will see from here, I don't have enough space, and then I'm bringing it just right here. Because 4 plus 3 is 7. If you check, we'll never leave our answer in exponential form unless stated otherwise. But if not, proceed. Tell us what is 2 to the power 7 as a whole number, as it is now in a form of exponential. It's like a reversible thing. We had 8 at first. We change it into exponential. Now we're having exponential. We change it into a whole. So obviously, the answer here will be 128. How did we get that? We know that 2 times 2 times 2, like the same number multiplied by itself 7 times. I'm referring to those who don't have, those who don't use calculators more often. So this is what we mean. There should be like 7 of them. 1, 2, 3, 4, 5, 6. Then voila, 7. So 2 times 2 is 4. 4 times 2, that's 8. 8 by 2, that's 16. 16 by 2, that's 32. 32 by 2, that's 64. 64 by 2, that's 128. Now, again, so they say to you, simplify. So it tells us that they actually wrote all this, just for that. So everything that you see is so much complex. This means just 128. So they presented a number like 128 in the most complicated way, as they say, simplify. If you make sure that everything that you're dealing with, focus on the topic thoroughly. So don't just rush to say, since you're doing exponent, your mind is thinking about the function, you are thinking about geometry. No, whatever topic you are busy with at that moment, give it your all. Then move to the next topic with that confidence. So now, I think now I'll do problem number 4. Cherry on top. Let's see. Before I do that, let me clear the board again. Pause. As I'm cleaning the board here, you can start to work out on problem number 4. Work out problem number 4. Okay. I can comment phela nine. Commentang batho ba gaso, commentang my good people. Commentang. We are at like 42 minutes now. I said watch this till the end. Now let me bring this problem right here for better space, enough space. I'm having a 4x minus 1 plus 4x plus 1 all over 17, 12x. Nice. Now let me clean this mess so that, okay. And here we are done with that. Again, let's observe. Observe the problem itself. And you ask yourself some questions. What is the first thing to do? What is it that I'm going to do in attempt of providing the solution to this problem? Remember, they want you to simplify. Just like the previous one. They gave us complex problems, but at the end we just find solutions. Answers like 25, answers like 125, 4 over 3. But at first it was just a very much complex problem. So now, pause the video, work on it. I will start. And then I might identify that I'm having the same base, meaning I can start by just taking out the common factor, right? It's doable. You know, in maths, we cannot say you're wrong until it's proven otherwise. The nature of this kind of problem, previously we've seen that when you take out the common factor, there will be some sort of cancellation. So these take us there. 2. 12 can be changed in different forms. 4, we can just leave it as 4 and split. But will it accommodate this where there will be a cancellation of that 4x? Because you can see this 4x, if we take it, we can take it as a common factor. But what about 12? If we change 12 into exponential, 12 can be 4 times 3. That 4 can also cancel. And then I can use 2, 2, 2, 2. That means when you say 4 by 3, 4 will be 2 squared. So it's going to be 2 squared times 3. I think the answer will still be the same. Mathematically, we are not wrong until it's proven otherwise. But not with misconception. Learners are very creative. Something that is wrong, they'll just manipulate until it seems like it's right while it's not. Now, since I've got the 4s here, let us just do this. Split. Now, since I'm using the 4s, I need something that has 4 on a 12. Now, let me work out on the 12 here. 12 is 4 by 3. And 12, of course, has an x there. So if I solve this to be that, my x still remain. Therefore, if now I say they've got the exponent of 1, so I'm going to say 1 times x. Now, believe you me, this become that. I can go and plug it there. Because I see the cancellation of 4 taking place there. Even if a learner who applied this in a different form, that will be like, when you say 4 times 3, that a 4 can be 2 squared. This still gives us a 12. That means it's going to be like 2x, 3x. But when you check, this is for a learner who will be forced to change 4 4s into the base of 2s. So a learner can still change the 4s into 2s. But now I decided to use the 4s. Because my observation from distance, I realized that, no, man, I've got the same, I'll have the common factor of 4 to the power x, including the one representing my 12 to the power x, which I decided to go with 4x, 3x. We're trying to simplify. Now, look at the numerator. You can identify that there is actually something common. And always understand, when you talk about something common, we always talk about the operational sign of addition, that it separates this side from that side. So this side is something common, which is 4x. Even the other side, I still have a 4x. I refer to 4x. Basically, I mean 4 to the power x. I think you understand. Now, I highlight this and that. They are very much identical. That's how you spot some common factors. What do we do with common factors? We take them out. That's like part of factorization. So if I take 4x outside, you tell us what's left there, remainder or something. But this one, our denominator, remains the same. I cannot take out, there's nothing common on this denominator part. Nothing is common. Because there's a multiplication in between. If there was an addition with something similar in both sides, yes, it was going to be considered as a common, but it's not the case. Now, I said on the previous problems that once you take out the common factor, in a space of that common factor, replace it with 1. This one represents this circle. Then there is a multiplication. I put it back. There is 4 to the power negative 1. I need to indicate that too. There is addition. I take it back. There was a 4 to the power x, which is now, because I took it out as a common factor, then I'm going to write 1, like I said. Now, there's a multiplication indicated, then there's a 4 with a 1. We know this one will never affect anything. The nice part about this is the moment of celebration is when now I realize that, wow, now I can just cancel. I didn't forge this. I know learners are very good, very much creative. They'll just do something that is like actually totally out. Convince themselves to be right. And even manipulate the teacher to make it right. All right, now, again, we cancel if there's a bracket involved. If whatever that is outside the bracket as a numerator is similar to anything that is part of their denominator, and then we are welcome to cancel. I think I repeated this 3 times from the previous solution. Now, let's write this, whatever that is remaining. Now, after cancellation, I'm left with this. My numerator is still a bit complex. However, my denominator, basically, let me put it, my denominator is not that much of a problem, because this is what is left here after cancelling the 4 to the power x. Now, let's work out on my numerator. I said PEMDAS. Some, they replace B with P. That is for another day. Let's focus here. The moment we see the exponent, don't just say 1 times 4 to the power. No. At some point, you'll be lucky that the solution is correct. But we want you to stick to the law so that next time you find something unique, you still follow the rules. You'll never go wrong. So we know that now I must sort out this mess. 4 to the power negative 1. By now, you should know. There it's 1, remain untouched. Then we're having 4 to the power negative 1 is just 1 over 4. We did explain that. Now, there is my addition. I show it. There is 1. There it is. Multiplication. So obviously, 4 to the power 1 is 4. That means I'm done with the part of exponent. I sorted out the exponent. Now, what comes after exponent is basically multiplication. If there's any multiplication on your expression, now if you check, this is multiplication, this is addition. Multiplication, addition. Which one comes first? Multiply first, then you can add after. So step number 1 is multiplication. So basically, what is 1 times a quarter? Is just a quarter, or 1 over 4. Then what is 1 times 4? That's 4. But all over 17,3x. The nature of this problem, they've got a tendency whereby the variable cancel each other. Now, this proves that it's not always the case. Mostly when you practice, the problem that you come across, you find that there's cancellation of x, and then you're just left with a constant number or something like that. But now this proved to you that it's not always the case that the variable disappear. However, they forever use the x variable does not mean it will forever disappear. That's the proof. Because some learners, when they come across this, they start to assume that they did something wrong. They can just get rid of x and having 17 times 3 give the answer. No. Avoid self-doubt. Never underestimate your thoughts. All right. Now, again, I know, learners will punch a calculator and give the answer. There's nothing wrong about it. But understanding is the key. This is grade 8 syllabus or primary level, I think, whereby now I must get the LCD. 4 times 1 is 4. Why? 1 can go into 4, 4 can go into. So I just decided to multiply. And if you got your LCD by means of multiplication, that means your numerator also, we can just multiply. Cross multiplication. Since it's addition, I said the order doesn't matter whether you start with the right hand side or left hand side. But usually I'm used to right hand side to say 1 times 1, that's 1. 4 times 4, that's 16. Remember, this is just a part of this numerator. All over 17,3 x, or multiply by 3 to the power x. Now, furthermore, this one, when I simplify, is going to be 17 over 4. All over 17 times 3 to the power x. I can say now over 1. Since, well, this is a fraction, I want to create this to be a fraction too. Can punch a calculator, it will just give you this. But like I was saying, a calculator cannot do everything. You cannot punch this. You're forced to punch only this portion which give you that. You still need to know application of mathematical skills. Now, let's move on. We are having a 17 over 4 multiplied by. This is me now switching to BODMAS. That means division, this division line will be replaced by multiplication. And the only time I do that, I need to switch my numerators and denominator. Like basically, the reciprocal of 17 times 3 over 1 will become 1 over 17 times 3 to the power x. This is what we celebrate to say now, you know what? 17 cancel 17. For you to provide the answer, you can write what's remaining on your numerator. I only have 1 there. It's my 1. On the denominator, I have 4 times, or 4 times 3 to, this is the solution that I'm getting. I know what you are thinking. You want to say 4 times 3 equals to 12. Don't even, hey, just leave it. Leave it like that. 4 times 3 to the power x is hot and oil. They don't mix. Now, this brings us to the final answer. Look, they wrote 1 over 4 times 3 to the power x as what you imagine. This is complex, but this is the simplified version of that. I hope you understand how the exponents operate. More lesson to follow. Now again, if you find this lesson interesting, you gain something today, as this is the first video, first lesson, then you have to subscribe so you can learn more from Ngwasheng Maths Online Academy. Like I said from the beginning, this is just the beginning. It's part of term 1. Topic is exponent. I haven't touched the sets. That means the next lesson will be based on the sets. Guys, comment, like, share. All right. Thank you for your time. Thank you for watching. And If you still need clarity on some, you can still rewatch this video. Better yet, you can comment on the comment section below. If you need clarity, you've got questions, you've got suggestions, I welcome you guys. Now, the next video that will follow, I'll touch a bit of sets as well and follow the plan. If you want to know the plan, check the shorts that have been uploaded where I indicated what is it that is going to be covered for term 1 grade 11. Same thing goes to grade 12. With the grade 12, I'm gonna upload a video based on sequence and series. For grade 12, they're doing sequence and series. Grade 10, I think, is algebraic expression for grade 10s. However, grade 8 and 9, it's whole numbers. I'm going to upload all that. I thank you.